This is the line y equals x, and you can see y copies whatever x does. If x is 1, y is 1. Whenever x is 2, y is 2. And the equation reflects that relationship. Now, in the case of this line here, y equals negative 2x, well, x can have a value, but to get y, we have to multiply that value by negative 2 before we can plot it. So if x was 2 here, we must multiply that by negative 2 before we can plot it. So if x is 2, yep, if we multiply it by negative 2, we get negative 4. So here's our plot point down here. And equally, if x was negative 1, we have to multiply it by negative 2 before we can plot it. So negative 1 times negative 2 minus times minus is plus 2. Here's negative 1, and we have to plot it at this point here, which is the coordinate negative 1, 2. We defined gradients as when we go from left to right and we have to climb, as we do if we walk along the red line, then this has a positive gradient. But in the case of the blue line, you can see, look, as we go from left to right, we're going down the slope, and this has a negative gradient. So let's turn off the blue line, because I can demonstrate everything I want to show you just using the red. So yes, this has a gradient of 1. And here is the adjustment for that particular line. And I am able, with this slider, to alter the gradient. Okay, so let's make it 2. There's the gradient of 2. So if we took the journey from here to here, our rise would be this amount, which is 2, and our run would be this amount, which is 1. So the gradient is 2, and that's what the curve is telling us here. Here's the gradient. That same value. This program will also allow us to play windmills with a line. So if I keep on increasing the gradient, it gets steeper and steeper and steeper. Gradient of 6 went through, here's 7. Gradient of 8. Gradient of 9. And the maximum on this particular slider is 10, though you can program the software to do anything you like. But here is a gradient of 10. Okay, coming down, there's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, a half, because you can see gradients can be less than 1, 0.1, 0. So a line of gradient 0 just runs along the x-axis. I think you'd expect that. Okay, let's go into negative territory. Negative 0.1, and the line slopes down very slowly. How do we get 0.1? Well, let's find 2 points again. Let's go here, and let's go here. It's always good to make a point on the cross of the axis because your numbers are easy. What's our rise and our run? Well, our rise, but it's not a rise, it's a fall, so it's a negative rise, is a rise of -1. And the run, well, the run is all this distance here. From 0 up to 10, that's a journey of 10. So the gradient of this line is that fall of -1, or a negative rise, divided by 10. And that's where we get -0.1. And if we continue our journey round into deeper negative territory, the line will also respond accordingly. -1 puts it in a 45 degrees slope pointing downwards, and we can increase. There's -2, and all the way up to -10. So you can see we can really play windmills with the line by simply altering the gradient. But one thing I want you to notice, of course, is that it's always going through the origin, the point 0, 0. Let's pop it back to the gradient of 1. So if we wanted to draw any straight line on this pair of axes, we have to somehow unlock the line from that 0, 0 point, the origin. Well, suppose we take this line, and I'll put some points on it to make it really clear. and add 1 to the y direction of every one of those points. So this point would be here, this point would be here, this point would be here, and so on. So we would drag the line upwards, away from its home at the origin, and it would sit along our new row of points. What would the equation be there? That's where this second slider comes in. So if I start moving this slider in a positive direction, the line will very slowly move up. And eventually we'll move it up so that it meets our new points. Point 1, point 2, here it goes. And there, it's now going through our new points, which we moved in a y direction of 1. So yet again, this software will allow me to vary the amount of lift I give the line by altering this slider here to the value of 2, to the value of 5. And you can see the line is not altering its slope, it's simply altering the point at which it intercepts, and that's the key word, with the y-axis, the vertical y-axis. Here we have an intercept of -5, and here we have an intercept of -3. And of course, at any one of those points, I can play windmills. So with those two parameters, the gradient and the intercept, I can draw any line on this two-dimensional coordinate system. So we need to form a general algebraic expression for a straight line, given the fact that we've got these two parameters. Well, the parameter of gradient, we tend to give it the letter m, and the parameter of intercept, we tend to give that the letter c. So the gradient multiplies the x, and the c just adds something to the equation, adds something to y. So the general expression for a straight line is y is equal to mx plus c. And that's an important equation to remember. And the gradient and the intercept work totally independently. We can look at the intercept of a line, and in this case it's -3, and there it is. And we can measure the gradient by looking at the rise over the run, and in this case the line's gradient is 2. And just as we can play windmills at any point of intercept, for any gradient, we can alter the intercept. But before I end this tutorial, I have one word of caution. The values of m and c in this equation are only true if we have a single y on this side of the equation. Not 2y, not 3/4 y, not 0.78 y, it's got to be y. And you'd have to rearrange the furniture and solve the equation for y before you can truly say that 1.2 is the gradient of this particular line and 2 is the intercept.